So this is the KBB valve, and it's designed as a safety device. You can see on the top of it there's an arrow showing the direction of oil flow, and this is the on-off switch. So I'll just demonstrate how this works. So you can hear air going through it or oil going through it. And when I pull this, you'll hear it stop. So that's it off. Press it down to turn it on. So that's the KBB remote sensing fire valve. So the KBB valve is a safety device triggered by heat being applied to this sensor. So if heat's applied to this sensor, it will automatically trip the valve off and stop the flow of oil, and that's its primary function. They come in two temperature ratings, 65 degrees C or a 90 degrees C, and you can place the sensor in a suitable position so it can act upon any heat that shouldn't be where the sensor is. So these are the components that are going to be screwed together to allow the oil to come from the valve into the pot. So we've got the descaling device, and this device has got a lever that you rotate, and it then is bent at this end so it rotates around the outside edge of the descaling device to clear any carbon build-up. So that screws into here. Then the pipe fits into here. Then the pipe fits into the valve, the outlet of the valve. This is the inlet to the valve, this is the outlet. So that's the setup. For the purposes of this illustration, we've jury rigged up an oil tank, which is only about 6 inches head above the oil valve. Should be about 12 inches or 300 millimeter above the valve. So we've got the oil tank, we've got a flexi feed into a KBB, into the valve, and this is the valve outlet, and we're going to demonstrate the flow rates that we should get when we're setting up. Right, first check in making sure that we've got a good oil supply is disconnect the oil pipe from the valve, remove it and turn the oil on. Make sure we've got oil coming through at this point. Right, so we've got oil flowing there. We don't need a vast amount of it. That's adequate. So that's the first check completed. Right, problems. When you're starting from new, this area here is a problem. You can see a tiny little slit there, and that slit is cut through a piston that slides up and down this cylinder. The slit is raised or lowered by the action of this rotary knob, your oil flow control knob. So the more you open it, the more it's exposed to the oil level, and the more you close it, the less it's exposed to the oil level. This slot is minute, as you can see, and all it needs is a tiny little series of air bubbles in there to stop oil flow. So this can be cured by tapping the valve lightly with a plastic handled screwdriver. So we've checked that we've got oil coming out of this pipe, and in theory the oil now is going into the valve. Next thing we need to check is the valve's cocked into its on position. So we just lift this little lever up and that cocks the valve into its on position. Then put the valve onto full flow, maximum flow, and oil is now dripping out of the outlet. That's full firing rate, so it's quite a quick drip. Drip, 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 drip. If I turn it down to low firing rate, you'll see the drip slow down substantially. So now we're on drip, 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 drip. I'll go back up to high fire. Drip, 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 down to low fire. Drip, 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 drip. Right, so on the first firing, we've got the oil into the valve. We know the oil is coming out of the valve. Now the oil has to fill this pipe and then start entering the pot through the descaling device. So when we turn the valve on initially, it has to fill the whole of this pipe before it can come out of this end. So a little patience is required here because it doesn't do this quickly. It'll take a bit of time for the oil to fill this up and come out of here. Bearing in mind that the flow rate on low fire is 4 cc's per minute and on high fire 12 cc's per minute. Right. If you're unsure about doing it over 15 seconds, we do it over 15 seconds because it's quicker. And when we're out in the field servicing, we want to obviously be in and out of a customer's house as quickly as we can if we have to do this. But the best way to do it is to do it over a 60-second period, and you'll find that you'll be more confident and it's more accurate. Right, so this is a CC glass, and you can see it's calibrated 5 cc's, 10 cc's, 15 cc's. So to do a flow rate check on the low fire, we're going to turn the valve on to its low fire position, and we're going to get a stopwatch and do a 15-second check.
I can count 15 on here because it's got...
Yeah. So we're going to do a 15-second check.
Right, go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right.
That's how much we've got.
Yeah, that's how much we've got in 15 seconds. So if we multiply that by 4, that should give us a reading. And the reading we're looking for is 4 to 5 cc's per minute. Right, to do a high fire check, same again, put the valve onto high fire. You'll see the flow rate rapidly increase and start again on a 15-second check.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Turn the valve off, and that's a quarter of what you need per minute. Right, so whilst we're on the troubleshooting issues with vaporising pot burners, which is what this is called, a vaporising pot burner, it's pertinent to go through one or two issues with these. The main issue being the way it works. A lot of people are under the impression that oil runs in to the pot and it burns as oil, and that is not the case. Oil approaches the pot, and as soon as it gets into the pot, at this point here, it immediately turns into a vapour. So effectively, this is a gas burner, not an oil burner. The issue with that is that the burner has to come up to temperature quickly, and this is always a problem with starting the burners. When the oil runs in, we've got to get the burner up to a temperature that will cause the oil to vaporise and turn into a gas, so then it effectively becomes a gas burner. But before it can do that, it has to come up to that vaporising temperature, and this is where the difficulty arises. If you put too much oil, if you allow too much oil to go into the bottom of the pot, it kills the temperature of the pot, and the pot can never come up to vaporising temperature, and what happens is the excess oil just burns as oil. This situation is unpleasant and can be dangerous, because once you've got a flooded situation, the pot can burn for hours until it reduces the liquid oil to a vapour. We've got to avoid flooding the pot at all costs. And the other thing we've got to avoid is letting any carbon build up inside the pot. If carbon builds up in the pot, it acts as an insulator and stops the pot coming up to its critical temperature. So excess carbon stops the pot working as a vaporising burner, and all we get in that situation is dirty yellow flames, loads of soot and loads of future problems. So if the burner doesn't operate in a blue flame condition, don't run it. Turn it off immediately and clean the carbon out of it, or check the oil's coming in at the correct flow rate. The other problem can be caused by the same problem, airlocks in this pipe. Again, the slightest airlock in here will stop oil flowing. And the reason this occurs is because going back to the initial illustration, we've only got a 15 milli or 15 to 18 milli head of pressure, oil pressure, on this to create the flow that the burner requires. The way that the pot comes up to temperature and converts the liquid oil into a gas, burning it as a gas burner. That covers the fuel side of it. The other side of it is the air side of it. So before combustion can occur, we have to have a suitable amount of oxygen, and that's drawn in through the action of the chimney. So the chimney applies a vacuum to the pot, and the vacuum draws air into the pot through these tiny little holes. So you've got a string of holes there and these small holes here. That provides us with what we call the fuel-air ratio. So we've got a controlled amount of fuel going in, and the air is controlled by the chimney vacuum and the size and quantity of these tiny little holes in the burner. This is a very, very accurate state of affairs, and it took the designer of this pot a long time to establish the correct fuel-air ratio. On boats, the fuel-air ratio is a particular problem. because we only have short chimneys. So short chimneys are not capable of delivering a vast flow of air through the burner. So we have to adjust the burner to work under the conditions that we can generate with a low flow.